I'm also recording this. So we have it. Thanks. Sorry I can't be there. After a 7-hour delay, they canceled my flight, so I couldn't get there. And then they decided to cancel the flights on Tuesday and Wednesday. So, but we have all the content, and we've got great people there. I wanted to point out this event that's virtual, that's on demand. It covers all the cool new stuff. I do a section on the end about streaming. Worth taking a check out. Pretty easy to watch. Now, we also, for people who want to play around with stuff before you get ready or run this on your laptop, we've got a community edition of our streaming tools available. They just need Docker and some RAM and some decent RAM. It's a pretty big setup. And we're going to cover streaming today. Certainly, there's a lot of other stuff that Cloudera does, and we'll make Ian answer all those questions. But we're going to talk about different streaming use cases, going through a lot of demos. I don't want to do too many slides. We'll share these slides with you. I have them already posted, so you'll be able to find them online, and we'll be able to share them with you pretty easily. But we're going to cover all the things you need to be able to switch from doing a batch to real time, but doing it securely. And it doesn't matter where you're going to run it. So if you're running it on premise, you're running it air gapped, you're running it in public cloud, private cloud, any combination of those, you're running it on small portable device, run on a solar panel, you could do that too. And we're going to cover a couple of common use cases and hopefully answer some questions, show you some new stuff, and then go in deep dive later into any questions people have. And if anything isn't answered today, we definitely do follow-ups virtually or in person, and we could schedule that. Common is to have some kind of IoT device is a big use case, and we have an agent we could put on either them or on aggregators or routers nearby to those devices, depending on how small you go. Big data stores and databases, another common source of data. And then all these kind of REST feeds and other feeds you may get from lots of different sources, whether it's different agencies or public data stores. Those are pretty common. The most common thing that happens after that is ingesting it somehow, whether that's a push or a pull with NiFi, and then NiFi sets it into high speed, either streaming that right into Kafka so we could have that buffered and distributed everywhere, or right into storage. And again, all these can be multiplexed, happen at the same time. You can go right into Spark, right into machine learning, and all this in that same secure Cloudera manner that we've always done, with security at every point. Everything can be encrypted, SSL everywhere, that same Ranger, Atlas, and Knox that are part of the whole stack, and everything can be visualized with our visualization tools or with whatever paid or free visualization tool you're using now.
Right, so hold on. So yeah, what he's saying in a nutshell, go back one slide there, is we have many folks using IoT devices today and ingesting data directly. So on the left-hand side, moving this way, is allowing you to deploy an agent close to the gateway device or close to that central device, and then allowing you to ingest directly, which could be encrypted. I had conversations about that today. And once you have it here, then you can deliver this data using Apache NiFi to various places. Obviously, in our stack, we have these types of tools, but depending on what the use case is, and if it's warm, cold, warm or hot, cold data, how would you like to use that to that point? Once it's on the platform, then you have, of course, the capability to do batch analytics. You can do machine learning and analytics as well. You can do real-time analytics, which Tim's going to show you today, and that includes visualizations, which is going to be served downstream. And you can do all of that, of course, with security analytics end-to-end, including lineage as well. So this is a big advantage.
Very cool. Yes. What he said. And this is just adding some of those other things that we talk to. Obviously, we can talk to a lot of things that aren't part of our stack. like Databricks and Azure and Elastic and Dremio and Snowflake and Mongo and Redis. It doesn't have to come from Cloudera or the open source for us to be able to talk to it, get data from it, and have it as part of your real-time solution, which is important so you don't get stuck with data that you can't distribute or analyze because it's in some locked location or format. We
We
make
all felt the pain from Splunk in this room. I think we all know what he's talking about, right?
Hey, for this shirt.
no need.
You can make it.
Now, just a quick highlight. We're going to mention a lot of different tools, and they all have different places where they work best. And certainly there's some overlap, but just quick highlight. You may have already been using Spark. That's generally best for ETL, batch, larger files, things that need to be scheduled. There's a lot of good things you could do with Spark. If you don't know what you're going to do with the data, you want to be able to change it quickly. You want to be able to react to things as they happen. Small files, lots of events, lots of records, continuous streams of things, running different JDBC queries. NiFi is the tool. It's usually the thing that touches your data first and maybe gets it ready for the final use of it, or maybe just puts it into something to get to that next step. And then the final place to run analytics in real time against your data is Flink, which is super fast, super scalable, and really the place you want to be able to take these streams of data, run queries on them, use it to sync it to something else, ingest change data, capture streams from databases, join streams of data together, look at windows of data, produce real-time materialized views. This is really the place where you can make really fast decisions on data and be able to do that with SQL in a pretty easy to use tool. And we will dive deep into demos and using that tool. I want to spend more time showing you how these can build cool apps.
One second. So who here has used Netflix before?
Yeah.
Right. So Netflix is entirely built on the back end of Flink, and it allows them to handle millions of events per second. Right. So this is an event processor as well, and it's very much used in production in some very large companies, as you just mentioned. Right. Think of them.
Yeah, some of the largest workloads in the entire world are running on Flink. Entire cloud providers and petabyte scale, thousands of servers. We haven't seen a top end for Flink. I'm sure someone will try, but it hasn't happened yet. That's my cat. We support a lot of different syncs for data. I wanted to quick point out ICEBERG. We just got a nod from Databricks that they're going to support using a way to access this format. It's used again by Netflix. Again, if you think of scale, it is a great way to store data and do it pretty easily. And it's supported by the whole streaming platform we have, as well as a lot of other tools. So something to think of if you haven't looked at it yet.
Let me plug it real fast. So one of the big advantages of ICEBERG is it allows you to basically get away from worrying about if you need the Parquet or ORC files for the downstream services. You can abstract that out, and that's a big advantage. The other one's the point in time, the ability to basically say, give me this table on this date, and I want to see what it looks like, and then you can of course move forward. And if you think about audits, Patrick, I'm looking at you for ML models. This is exactly what you would need to demonstrate that. Or if you're European Europe, not our case there, but you could demonstrate that an individual's data is not in a table when they built an ML model. It's a very strong capability, and it works all of our tools almost seamlessly in a way.
It's getting better.
Yep.
New release like this week happened. Yeah, so ICEBERG is cool and the logo's not bad. So I like it. Pretty easy to work with. But we have a lot of different things we talk to. Again, it doesn't have to be one of the Apache open source projects. It doesn't have to be one that we support. We're adding more and more of these connectors. If you have some you haven't seen, definitely reach out, let us know. We're always looking for more things to read from and send data to. So definitely let us know. Now, one common use case is working with collecting a lot of data really quickly, especially in cybersecurity use cases, logging, where, as something happens, you want to be able to react to it right away and be able to produce alerts, be able to send that to downstream systems, and to make sure data is stored when you do that properly and can be compressed and encrypted and all those sort of fun things. And common use case, again, we from NiFi or from Minify, if you need to, we can read lots of different kinds of logs, whether they're on Windows, they're on Linux, or other OSs. If it's over TCP/IP, UDP, files, SFTP, lots of different ways we can read the files, whether we're tailing them, whether we're reading the whole file, whether we're getting events pushed to us. This is pretty common, and usually that goes into NiFi. NiFi has a lot of tools to be able to read, process, enrich, and transform them. Then we usually get them into a Kafka buffer, so that can be shared with, giant clusters of, say, Flink, where you could do those analytics real time, but also get those stored into a data warehouse for additional processing and machine learning workloads, and lots of fun things you could do with this data. And this has been proved out for a number of customers out there. And it doesn't matter if that's in your data center, it's in different cloud environments, or any combination. If we need to push, pull, or put an agent there, we could do that. Or if you need to ship it to a different server by some other means, that's fine as well. Let me go through a couple of these slides quickly. Some of these slides are from the talk I did at Cloudera Now, so definitely watch that. That's a really quick watch. Two of the ways that we make this a lot easier to develop is we have tools that require very little coding. It's not no code, because you can never get away from all code, but it lets you do things like drag and drop, lets you do things like SQL. Pretty easy to be able to let everyone who has some programming skills, but not 10 years to distributed programming, to have to run these things. And I'll show you that when we go through the tools themselves.
Yeah, it runs SQL on top of a streaming data set is pretty incredible. And this allows, and he'll talk about it today, continuous queries is a huge advantage as well. But leveraging the skill set that you have in-house, your SQL skill set, is a big advantage here.
Yeah, it's pretty cool. And it's not just on top of streaming Kafka, but it could also be directly getting change data capture from databases. It can get it from other data sources. It's pretty neat. It makes developing code really easy. And some of the reasons why that becomes important is when you're trying to analyze logs before maybe you push them to Splunk, which we have a number of very large companies doing, because the amount of savings there, while giving you benefits of speed and reducing network push that you're putting out there, and being able to find things before you even get to Splunk to do whatever analytics you do there. You can get these things the second an event is born. You're on top of it, can do analytics and send alerts before it even made it to that next system, which is very helpful. And again, being able to integrate that with your machine learning or whatever else you may have, very important. And the flexibility in the platform is very impressive, and we'll show you that. The first portion
and
of
often what we're finding, sorry, I was gonna go back to the last slide real fast, but yeah, so the cost savings, alone, just from Splunk can actually pay for this.
Oh, yeah.
Think about the cost model being very much how much you pay for how much data you pass through that. So if you can just filter that down to say 10, 20%, and save money doing that as well. So think about it like that. And then, of course, you're not getting locked into this Splunk proprietary data format. It's very open.
Teed up question, how much can NiFi reduce Splunk logs by?
It's probably 60 to 70%. I mean, maybe more, but I was off the top of my head. I'd take that off the bat.
Depends on how smart your logs are to begin with,
Yeah.
which my guess is, this was from a very well equipped company, a lot of engineers, a lot of programmers there. They don't have default settings on for logs. So I mean, it could do pretty well. I mean, there's so much noise and so much redundant stuff in your logs. It's not too hard to reduce them that first step that you touch them. But having a tool like NiFi that doesn't require constantly being redeployed, can react if files change, which is a common thing with logs, being able to read logs, even if it's different versions of formats, things change, it won't break NiFi, which is important when you're reading stuff that's not, extremely well defined. Maybe it's a little, it's semi-defined, fields come and go. Not going to break NiFi. It doesn't have a fixed schema it has to work with all the time. I'll show you some of that flexibility in some of the demos there. But yeah, that's helpful. And you'll see once you start using NiFi, like one of the airlines, you start using it for everything because it's just really easy and performant for most use cases. And then sometimes you need a smaller version of NiFi, like you need to be able to deploy it on small device. Of course, it's green.
It's probably Tim's cat.
The cat stole my device, man. Yeah. There's a lot of devices here, man. It's green. I don't know.
Yeah, so
There's a lot. I have a lot of cat stickers that I wasn't able to give out. So next event, we will definitely get you some of my cool stickers. So these small things, we have them written in Java. And what's nice about that, it's NiFi with the top taken off. So you can't edit it there. And you push that out to whatever. It could be a server. It could be our oil company friend puts this on every desktop. And they use this to read cybersecurity logs on machines. So instead of having a Splunk agent, they use our agent that has intelligent code at the edge that can be auto deployed, filter out just what you need and send it on. And then if you don't want to have to send all that data to Splunk, but still keep it, you could push that to our data stores, which you could just store it in, S3 or Ozone or something pretty cheap. And then still use it for analytics or for training machine learning models. And we also have a C++ one that runs even lighter if you need to push that out to smaller devices or to Docker containers, what have you. And I'll show you the tools for that one. Pretty similar, a little different because of the way it runs, because it's running by itself on these little edge places. Next up is Kafka.
1 second. And this is ideal for core light sensors. This is ideal for Palo Alto logs. There's a lot of things this is ideal for. And the C++ agent gives you additional flexibility on smaller footprint as well.
Oh, yeah.
So a lot of capability this gives you. And of course, we can, when he shows you the flow design at this point, you don't have all that. You push the flow out. So if you have different groups of, let's say you have 3 or 4 different types of devices, you can make a flow for type device A and just push them out. And then you can publish to the other types of devices too. There's a lot of real good ways to manage, point it in the flows as well. If you have thousands of devices, right, in many classes.
We got someone with 100,000 plus, and they're a couple.
OT devices, right?
Core light sensors.
Yeah, it could be theoretically, we've scaled it out to a couple million without a problem, running from being controlled by a very small server.
So you mentioned core lights.
Yes.
You actually have Your, connected between Corelight and Kafka.
I believe Kafka, like we do TSL across that and do that. TLS, sorry, TLS, yeah, across that. Yeah. And then we pull from Kafka. Do we have Kerberos for Minify?
I believe, I'm pretty sure we do.
Okay. Let's pin that when we'll get some documentation later.
Yeah. Take a note of that. We'll just confirm that. It may only be on one of the agents. It may not be on both. We have to check that.
Good question.
Yeah. And, it also has the ability to encrypt data before it goes over SSL to wherever it's going to go. And if you have your own proprietary things that you need to do, this can execute Python processors and custom processors. The Java agent will run any NiFi component. You could just ship the ones that you want with that agent. So if it's very minimal, you only need to do like 2 things, like tail a file, encrypt it, and then send it over some proprietary network. You could just have those handful of components as your deployment. And then the Edge Flow Manager, which is the manager for the software, is just something that gets pinged back to, and it doesn't even need to be pinged back. It makes it easier. It does not call out to the agents. The agents can call out to it to get information and to provide status, but we'll show you that in the tool. Next up is Kafka. Kafka is the great way to buffer all the data. It tends to be for us, we grab the stuff from somewhere, get it in some kind of clean format, hopefully have a schema if it's structured data, get it into Kafka topics, and then that can be distributed to everybody. You can also push right from a Minify agent, or you can push from third-party tools, other software, or your own custom Java, Rust, C++, Python. There's Kafka libraries for most development tools out there. For us, we mostly use it to buffer and distribute. It does have some other features, but those are the main ones. It is a great way for us to federate this out to a lot of consumers, which can be simultaneously Spark, Flink, NiFi, other tools. There's also a couple of neat features for doing change data capture, which I'll show you real quick. Do we have more? Ian, you want to talk about Kafka for a second?
Sure. So the way, the analogy I like to use when I is, Kafka is a think of it as a mailbox that's resilient. You can, anything that goes into it can be replayed, start. Consumers basically reading all of that, so you can distribute who's reading that. You can also give data different probes. So there's a lot of interesting capability there, but of course is the complete fallback too. So if you had events that you had to capture, reading events, and they were very important, you have to be able to capture them once and always replay them. That's the big capability with Kafka, and it works incredibly well with the rest of our stack.
Yeah, you can replay back to the first message. You can keep stuff in Kafka as a buffer as long as you want. It has some nice features. We also have a geo-replication agent with it. So if you want to distribute it to different clusters around the world, you just a couple of configurations, it'll handle it for you, which is really nice. You don't have to write any code, don't have to use any proprietary stuff. There's an open source replication management for that. Very nice feature. I'm going through it quickly, but there's entire companies that just sell.
Oh yeah, yeah. We have parity with in our offering.
Yeah. Yeah, it's Kafka's Kafka, but we make sure it runs, and we have the most data going through Kafka of any company in the world.
And let's jump to the demo. You think we'll jump to the demo real fast?
Yeah, we go right to demos.
Let's do that.
I mean, slides, you could download the slides. Let me get stuff running here. I guess we'll
pass with lasers. If the lasers didn't make it, it is what it is,
be okay for demo?
Yeah, let's do it. Let's do it.
Okay. So I am starting at the edge.
All right, so this is the, he's gonna show you the editor for the end device. That's what he's gonna start with.
Okay. Okay, so this is the edge management software. This receives all the heartbeats and the information from these agents, unless you turn the agent's ability to talk back off, which you can do. If you're in some kind of secure environment, you could use this device, have this talk to it, get its configuration and everything set up, and then disconnect it from any other network if you need to. And then when it's ready, it can connect back.
Hey, Tim, do me a Command Plus to get a zoom in, my guy.
Let me know.
Keep going.
Keep going.
Oh, yeah.
There you go.
Stop.
That's good.
We're good.
Thank you.
Dude, this is like for me, but this screen is where we do the monitoring. And this is getting back all the different classes that of devices I have. So it could have as many as you can imagine. There could be hundreds, there could be thousands, like I said, 100,000, 1,000,000 potentially. I've got different classes based on the type of device. Like one of them has environmental sensors, one of them's running on a Macintosh, one of them is a Raspberry Pi 400. So there's different groups of them and they have different agents. This is a nice summary to see what's going on. Behind the scenes, there is a full, let me see if I got that up. Somewhere I got it up. A full Swagger interface to this if you need to look at REST endpoints, or you're not concerned about seeing it in a UI. You want to, get that information. It can also be pushed to Prometheus and Grafana for that sort of fun stuff. Here is where different events are, and they can be, you could break them down by all the different things you see here. You could change the sorting, all that kind of fun stuff. You could drill down into them. Again, everything you see here can be grabbed with REST. So if you don't want to have to use the tool, this is a good way to see summary of things going on. Down the manager is a little more of the same, but this one is, to me, this is a nicer screen for showing everything about all the different deployed agents. And you could sort them by all the different fields. And here you can see the class. A class is a group of devices that can have as many as you want. And this is a good summary of what's going on. This is one of my classes. And this is how many versions of the code there is. This is a link to one of the agents. I didn't name it, so it got its own name here. And there's all a bunch of details about that, which you could get. Again, if you need this not visible, this can all be prevented from being visible or not being sent back. But it's nice if you have the environment where you're allowed to see what's coming from the edge, to be able to get all that detailed information. And even cooler, if something doesn't seem right and you want to know more about what's going on with this particular device, I click debug agent. The next time that agent calls back to me, I am going to give him a message telling him go into debug mode for a call. And that debug mode is requesting configuration and logs. And that will get sent back in the next request that it does. And then I'll be able to look at that. And it's pretty nice. Okay, it completed. So I could download that. It's a tar of a bunch of files. And if I look into it, it's got the configuration for that agent as well as its most recent logs. So that's pretty helpful if you're trying to figure out what's going on with something without having to be there, without being remote. We could also go into the flow file that it's using and change it. This is the development environment if you want to use it. If you don't want to use it, you can code things in NiFi, and there's a command line tool that will convert it. But this is a lot easier. This will also, yeah.
So I'm gonna say the big advantage of this is that you drag and drop canvas, right? So the nice thing is no code. But this is what allows you to bring in data off these devices without a lot of development, right? So many of the things are built in that we've talked about too.
Yeah, and what's cool is this is specific to what's on that physical device. So if I put certain things here, I can request what's on there. So when I pick how I'm gonna code here, whatever feature I'm gonna use, it is based on what that agent has. So if I deploy a new component with it, I do a refresh and it'll show up so I can know exactly what's available on that particular machine. And again, it's drag and drop. If I want to connect things, I just connect them. And when I'm ready, I just do a publish. Here, this isn't valid yet. So it's telling me, hey, you sure you want to deploy that? You could. It wouldn't hurt that I have this unconnected. It just won't do anything. But, you know, so I should probably not have that on there. But here, what I'm doing is I've got something scheduled on a shell script every 15 seconds. I add a couple of pieces of one piece of metadata here, and then I push it to Kafka. And I also do an HTTP call out to my NiFi server. That could be anywhere. You could send the data. You could not send the data. You could put it in a file, have the machine shut down, and then when you bring it back to somewhere secure, you could turn it on and have it, you know, read all the data or just put it in a file. You know, it's whatever makes sense for your environment. It's pretty flexible. And what's nice is if you want to change it, you just do publish, and that will, when it does a heartbeat back, even if that's a year later, it'll grab it and change it then. Pretty straightforward, pretty easy to do a publish.
So it gives you lots of capability to manage many of publish the flows, pull back the flows, modify the flows that you're giving to them. And what he's showing you is the capability. The nice thing is you can do lightweight transformation there on the device before you send it across the wire, for example, and prepare it for where you want it to be done. There's a lot of capability we have there.
Yeah, a lot of things you can connect to, read from.
Do you want to show? I mean, let's do the SQL streaming piece to this, and like maybe work a little bit backwards.
Yeah, we'll start at the end and.
Yeah. So you're seeing how we're grabbing and collecting the data from the sensor. We're going to go to the end state where we actually have it stored in Kafka, and we're going to query against them. You can see real-time queries work.
Okay, I'm just gonna make sure in NiFi that I have everything started. The thing you'll know about NiFi is I could pause live data when I feel like it. And I pause live data because I wanted to have some built up for you. So,
The capabilities of its delivery once guaranteed system. So anything the data we pick up, it will guarantee delivery that one. Even if the whole device goes down, the whole server goes down, that data that's pulled up will then be delivered once. So that means you have no duplication of data on your destination, and you guarantee that you pick up an event and you get it. You get the data where it needs to be on the back end, wherever it needs to be delivered.
yeah, that's another important feature of Kafka is you can do things like exactly once, at least once, you know, depending on what makes sense for your use case. So this is SQL Stream Builder. It is the tool to be able to query live data, join together live data. On this, you can connect to as many Kafka sources as you need to, as well as other catalogs of data, including things like schema registry, Hive tables, other stuff. What's cool is you could also set up these virtual tables. And for me, I've got one, which is a upsert table. So this one's designed to be able to be inserted into, and it's a Kafka topic. So whatever is the result of my query, which could be the analytics that says, if I see something happening in real time, send it somewhere else. And that Kafka topic could go right to a dashboard. It could go right to a phone or however you need to do notifications, it can go right there. So that's a nice feature of that. We also have the ability to do things like change data capture. If something changes in this Postgres table, it's going to show up here instantly. And again, I can insert it somewhere. I can do a query on it, whatever makes sense. I could also make any of that data available in materialized view. And a materialized view is just a REST endpoint that I can make available as a cache of what's going on in my continuous data. And this is a easy way. We have none of them active. Yeah, they got to be active. This will, yeah, here's one. This will make this REST data available to anyone who doesn't do streaming, so they can get, you know, a cached version. This is good for using with a Jupyter notebook or integrating with some kind of dashboard that may not be able to accept data instantly as it comes in. That is something, depending on what you're doing. Let me make this bigger. Oh, it's probably big enough. This is an example one. This one is looking at live plane data. I've got a ADS-B antenna sitting next to me. That's pulling data off of all the publicly broadcasting planes, including those off of Joint Base McGuire. And you have that data. I can see that real time in my queries. And here I'm doing a max. I want to look at the maximum, minimum, average. That's just what I wanted to look at. But I could do things just to select star. I'll show you that one. And that'll give me every record as it happens. This one's doing a max, so it may not show everyone at a time. What's cool is not just in this display. It is running on a Flink cluster. And if we look here, you can see how it's named. And this is running from the source, which is that Kafka topic, and it's running group by and aggregates. Again, this, if you're handwriting this in something else, like Spark or MapReduce or even Flink code, this is pretty complex. But if you looked at what we ran, it's a pretty simple SQL statement.
Yep, and as you notice, since he's been talking, we have, this is live data. This is that continuous query concept we're talking about. Planes are flying over his house. His antenna's picking it up. It's being passed through, and then he's got the SQL query running, like basically looking on top of that Kafka topic, which that data got loaded into, and then you can see the results were kicking out. So this is a real-time dashboard of these planes because he's picking up the data and managing it. Right? This is a really interesting capability. But you see, this is why we call this a continuous query. If this was a batch query, you might have had 3, and that would have been it. Maybe you run the next day, you get 4 results, but this query is running all the time, and new results come in. So another plane comes over, it'll be a new row. And so you think about that, for that to a Kafka topic, where then another agent or another piece of software could be looking and listening for events hitting it. And then you can handle those events as they happen in real time, not 2 days later, as they happen. Right?
Not a minute later, not a second.
Not a minute later, the second they hit.
Yeah, and we can, as it's coming in, we could do, I'll show you some other ones where while that data is coming in, we do different things with it. Like, when we got, do I have one up? Let's open another one up. You could open a bunch of different jobs running. I have one to, it might be down this one. Yeah, this one is an insert. So I'm inserting into a table from the change data capture records from this other database. So if you need to move between databases as those things change, this will automatically do it for you. This will deploy this into a Flink cluster, which could scale out to 100,000 nodes if you are pushing petabytes. You're probably not, but you may be. Pretty easy to do that. Same thing for inserting into any of the other syncs we have. It's pretty easy to set that up. I showed you that in the virtual tables. You know, we can have like this sync here is the Upsert Kafka one. If you get things from Kafka, I can put that into a database. Anything that has JDBC, so I can have it pulled out of Kafka, put it into a table. Gives you a nice way to easily manage what's going on with different data sources. And you can do any kind of queries you expect to be able to do. And this one doesn't have any data yet, so I can.
Did anyone ever try to actually query over a Kafka topic before? Manually over scripting? I mean, I have. Yeah, it's pain in the ass, right? This tool, it's a streamline effect for that, right? And it's something that anyone that writes SQL can understand. That's the beauty of it.
Yeah, and what's cool is there's options. If you know what your data is gonna look like, and you're like, yeah, we all agree what it's gonna look like, I could set up like for ADSB. And there's other catalogs, we could set it up in Kudu format, whatever it is. If I know what those fields are, like for the aircraft data, I could set up a schema for it. And if I have a schema, everybody knows what it is. So NiFi will know, oh, these are the fields you have, these are the types, and this is if it's nullable. And then so will Kafka. So if I go into my Kafka to view it, I know what it is because I have a schema. See, I have this schema available from here, so it'll show you the data. It knows what fields they are. Even this isn't what the format is. It's in Avro, which is a binary format, which is a more compressed format for pushing data around. But I could see this in a human viewable format because we have that schema. And NiFi knows what that schema looks like. Like if I show you what's going on, there's a lot of steps, but it's all straightforward. There is an agent running, which I showed you. Let's go to this guy. There's an agent running, and that has that antenna to connect to those ADSB messages. That's broadcast locally on that machine. That's how we get this screen. So I read that data feed at that device, and then I push it into, if it's not empty, I send it to NiFi. And that could be SSL. I can also, if I need to, I can encrypt it before it even goes over SSL. You need that extra step. And then that comes in here. It could go into a dedicated place, but why? I could just handle as many things as I want. So when it comes in, I send it to my processor for aircraft. And I do some formatting. I split the data apart. I pull out only the fields I'm interested in. Then I break it down even further because the format that it comes in is ugly. I don't like it. It also doesn't have a timestamp, and it doesn't have a unique ID. Who makes data like that? So I added a unique ID, added a timestamp, and then here I'm filtering out stuff where it's invalid data. Sometimes some military planes will block out some of the fields, so we don't need to see them anyway. So I will just send the ones there. I don't have to know those fields. If someone changes the field, it does not stop the flow from working. Nothing gets redeployed. This thing continues to run real time because this looks at the data and says, this is what it should look like. Let me map it up to the current version of the schema or the version of the schema that I said I should use. Write that out to Avro and send it on its way. And I didn't have to change anything regardless of what happens to that data. And we still have that full lineage, that full auditing that complies with every government standard, because this came out of the NSA. This is the full details of everything that I did to your data. Every person who touched it, how long they touched it, when they touched it, and a unique ID at every single step, and a unique ID for everything you see on that flow. So you know who touched things, when, how, plus any metadata that might came out of it, with a unique name for that data as it comes through the system, where it came through. Whoa, that's a lot of messages. This is on my laptop. That's the 3 millionth message that I've had come through the airport reader. That sends a lot of data. So that one went into there and I pushed it to Kafka and I could check that. We were in Kafka looking at ADSB and we could see it here. You could take a look as that data comes in. If you're using the full enterprise edition, we map out to everything that's touching it and we can push all that into Atlas. So you have a full lineage with all the other tools that you may be using. We put a key on this and we put a timestamp so you could find where things are easily. If you see this offset, that's where it is in the topic. So I could find every single record in, directly if I need to, or if not, I can just go roll back my offset to 0 and go look at that first record and, work my way through those, 100 at a time or whatever you're looking at, pretty easy. Data can be partitioned so more people can read it at once. There's a lot of advanced things you could do, but it's pretty straightforward to be able to do that. This is still running as more flights come in, and I have ways to look those up, and that could be another flow, and I could join that together. Sometimes I'll join this data on fields like this is a max min, so it doesn't make sense to join it. But if I take those out, I could, because I have a lat and long, I could do a nearby match to other things in that lat long. For flights, I'll match it up to weather data, which I have a live stream, and air quality, which has been relevant very recently, and put those together and have all this geo data around that important information. So if I need to make decisions like, oh, Tim's not going to make it in because his flight is very delayed because there's weather and air quality. And then I can also grab other sources of data. Like I have the US travel advisories that might say, hey, don't go to Milwaukee. There's too many people there. Whatever the advisory might be. Pretty straightforward there.
So what Tim is saying is he already knew that his flight was going to be.
I think he made me very well aware at 2 a.m. Let's just not discuss this topic. But in summary, my friends, I know we've covered a great amount here, and if anything is to share the capability, it's breadth of depth, right? We're not a one-trick pony. We do a lot of things here. Because there's not people like, you all do not have a single constituent stream of data. They all have their own need, right? It's the ubiquitous tool that looks at all those requirements, simple and seamless. Thanks to certain people that we like at IR, we've implemented the Python API. So that goes
Not me.
I'm looking at tell you because so it is what it is. I'll get to them later. So Tim.
Yeah, I wanted to show that preview of 9520.
Oh,
9520, about to drop.
so
This is
so
95.
folks, this is like the Apple piece that we do, like the developer piece right here. So this is the next iteration of NiFi is coming out, NiFi 2.0. The three committers that we've known that come
It's
with
in
it.
beta.
This from the jump. I've been very much focused on taking back a lot of the feedback. We've supplied it quite a bit from my Criterion folks, from NSA, from Sandia, from everybody else. And it's literally coming up to this. What you're seeing here is how Tim can easily add process and make like that much easier. You're gonna see a lot of things here, especially from the M2131 standpoint, the way that drop in, apply, you're good to go. You want to make it simple, easy, and seamless. And if anything, for all my SQL people out there that hate Java, you're right.
Yeah, right there, I used a Python processor, which is basically just pandas, which is converting a CSV file that I'm using a generator for. So this is synthesized data. We can synthesize data for testing based on a schema. So it'll be in the format that I expect it to be in, which is really nice. So not getting any weird data. I put 500 comma separated values in here. And then this Python app, which doesn't have any properties, pretty straightforward, is converting it. Again, it looks like any other processor in NiFi. It still gets all the data provenance. It is a regular deployable thing. What's nice here is NiFi can run on one node, 3 nodes, 100, 1,000. For you using it, you really don't notice.
What you're saying is we don't care about how much data you put through.
You could start small and then work your way up to petabytes, millions of records without changing your code. The only thing you might need to think about is, does something need to only run on one machine? Then maybe you should do that. Does it need to be delayed? Because I've had that problem that NiFi is too fast. Like if I'm calling third-party services, they may not want the speed I have to do, or if I'm doing a demo, I might slow down how fast I push the data. Because if I push 5,000 records a second somewhere to try to show you that on a screen is not very enjoyable. It's just and it's kind of pointless. So I could purposely slow things down. Like if I try to push data to Oracle, I could be too fast for Oracle. So I might have to slow down how I send them data. That's a common feature.
So no, dude, thank you so much, Tim. Let's kind of get some questions here. I know we're kind of getting towards the end of the night. Are there any questions for Tim right now?
Looking at you, Tilly,
I asked the question already.
and we gave you an answer.
Yeah.
All right.
We'll have more questions, just not.
Okay.
Since I know for a standing room only, it's kind of tough, but there's a lot. So.
Yeah, we'll get all the slides. There's a lot of things that defined more in depth. Different here are the different versions of NiFi, what's coming in 2.0, newer versions of Java, some faster things, cleaning up some old stuff that we got left over. One important thing that if you've used NiFi before, you might not have noticed is we added another kind of engine, a stateless NiFi that can be deployed as a function as a service. So it can be sent out there. Let's see if I've got this. Somewhere I have a slide for that. It'll let you deploy that to the cloud, just as you do Amazon Lambda. And it could do things like start and stop when data comes in, so you don't have to run a server. Kind of nice. A lot of different use cases out there, pretty easy to do, whether that's REST data, database data, sensors, log data, data from databases, very straightforward.
You've got paralysis by analysis here. I know that. I'm looking at you. I know, it's all good. So, yeah,
Is that Tim wearing his background jacket?
I think that was Tim.
that was.
Back there. There it is. There it is.
Nice. Nice. With a cat.
One out of my
In
full.
bakeries.
So yeah, folks, I know this is quite a bit, but in summary here, NiFi is a universal tool. We call this universal data distribution as a strategy, it's a concept, which time and time again proven through all of the clients. This is what we're trying to bring to the government. It's how can you simplify data ingestion, make sure that logs and any piece of data makes it to where it's important that it goes. Also, the downstream users that actually give a damn about that data. It will supplement their efforts, supplement the mission, and accomplish the goals. So we're really grateful for your time, and folks, if you need anything, you know me. Give me a shout. I'm happy to put these guys in front of you.
Thank you.
Thank you, Tim.
Thanks, Tim. Thanks, Tim.
No problem, anytime.
Person,
Oh, you do this.
Yes.
Yes.
I
Yeah.
thought that's
nobody noticed is like teacher, like for real. Like nobody's like a Captain Crunch person.
no one's seen this shirt before.
Oh my
It's one of a kind. I just had it printed for me, man.
Pretty today, folks.
Hilarious.
Yeah. Thanks, Timmy.
Thank you so much, Tim.
Appreciate you, dude.
No problem, man. Mail me some steak.
Cloudera now every month. It's the way to go.
There's a shorter version that sounds.
Much love to the wife and the family. Appreciate